Hey, how's it going? This is Mr. Hernandez, and I'm going to be going over this rational functions worksheet. Before this, though, in class, you were given this worksheet here where we uh, labeled what the domain is for a rational function, all real numbers except for what makes the denominator 0. We used uh, a rational function to determine what each point would lead to, because you're doing 1 divided by some value, and in this case we came up with each of the outputs. Also with dividing by 0, that's something that we're unable to do, and that gives us our undefined value, which leads to a vertical asymptote. And kind of looking at each of these examples, what makes this denominator 0 would be 4, because 4 minus 4 is 0, and that would be our vertical asymptote. And so our domain would be all real numbers except for 4. And when we look at a graph, those vertical asymptotes, it could be more than one, but those would also be listed in the domain as excluded values, all real numbers except for those x values that are the vertical asymptotes. So we're going to extend that into a couple of more examples, but even more so talking about the domain and range. And so I'm going to look at this first example. And before I start, I want to kind of just outline what the actual rational functions are. Sometimes when things are in black and white, it's hard to see what is part of the graph and what is not. So the blue segments are the actual graph. The red dotted line are the asymptotes. And so in this case, that's going to help us with the first question. With the domain, we're going to say the domain is all real numbers except for, and in this case, we're going to look at the vertical asymptotes. And this is hard to see, but it's -2. So this would be -1. And then this would be at +1. So that would be our 2 vertical asymptotes. And so that's where our domain would be excluding. And so if you want to put a note for yourself, the domain is consider the vertical asymptotes. Now the range is something that deals with the horizontal asymptotes, but notice there's like this gap right here. And so here at 1, going in the y direction of +1, we see there's a gap from there all the way to 0, which is this x-axis. And so when you talk about the range, you probably need to look for horizontal asymptotes. And so this would also be all real numbers, except for usually it's just the horizontal asymptote of 0, but really we want to kind of say there's a gap here. And so one way we can use interval notation is to say that it goes down forever, but it stops going up at 0. Not including that because of this dotted line, and that's why I'm going to use the round parenthesis. But also it goes from 1, and so notice that 1 is included because it's a dot. So it goes from 1 to, and I'm going to assume these are arrows, so it goes up forever. So this one's a little bit tricky, but the domain is really the main thing to that you want to feel comfortable with the vertical asymptotes. Okay, the y-intercept, there's a y-intercept right here. This is the y-axis, so you have to ask yourself, where does the graph cross the y-axis? And so in this case it's 1. And then we would write it like this. Any x-intercepts, that means where the graph crosses this x-axis here, and we see that that's a vertical asymptote, so these parts of the graphs will never touch it. Let's see, if we look from left to right, what is this graph doing? So this is either increasing, decreasing, or constant. And so this graph would be decreasing, and that's from negative infinity to, in the x direction, it's at -1. So decreasing from negative infinity to 1. And we also see, when we look at this segment, it's kind of, from left to right, it is also decreasing. And so here it's decreasing from -1 on the right side to the x value of 0. And then from 0 to +1 in the x value, it's increasing, as well as from +1 to infinity. So we could break that up as well. So from 0 to 1, it is increasing, and also from 1 on the right side of this vertical asymptote to positive infinity, it's going up. End behavior focuses on the left and right arrows. So this would be the left arrow. And so what is the left arrow doing? It's approaching, it's not going up forever, it's actually approaching 0. So we would say this y value is approaching 0. And then if we look at the right side, that's when x is positive infinity. So here's the right arrow. This right arrow is also approaching 0. Maximums and minimums, that would be something that polynomials kind of look like. If you talk about a maximum, you know, maybe looking at something like this, this would be a max, and that would be a minimum. But when you look at this rational function, these are not, they're not going to go down again. So these have no maximums or minimums. But this one here definitely has a minimum right there at that point. So that would be at 0, 1. And that's your max. And then continuous means something that you can trace over the graph without lifting your pencil off the paper. So for example, this would be continuous because I could draw this whole thing without lifting my pencil off the paper. But discrete means you have to, like, you know, lift your pencil off the paper to graph it. So if I were to graph this, this would be, I would have to stop here and lift my pencil off the paper to do this. And then I'd have to also, this one is a separate graph curve too. So yeah, this one I'm not able to trace over the whole thing without lifting my pencil off the paper. So that would be discrete. Odd and even, that's more for polynomials. So you could just put NA. Vertical asymptotes, those are pretty much these dotted lines that are given. So you have a -1 and +1. And whenever they're vertical lines, we want to write them as x equals. So this would be x equals -1 and x equals +1. Those are the vertical lines. And then there's no slant asymptotes in Math 3. That's more of a pure calculus type of thing. But the horizontal asymptote is right here. And with horizontals, we don't do x equals, we do y equals, and that one's right at 0. All right, so that's the first one filled out. This one here on the right side is pretty similar. So hopefully that can help you out filling out this one.